In this chapter, we're going to look at some of the mathematics related to owning a small business. In this lesson, we're going to look specifically at compound interest.
Okay, hi everybody. So here we're going to take a look at compound interest. Okay, so this is our first lesson in the chapter on small business. So here's what we're looking at here. Now, bear in mind when it comes to starting a business, most of us, don't have the money readily available to just spend on starting a new business. In many cases, we've actually got to go to the bank and get a loan, get an amount of money that we can use to cover those initial costs there. So when we go to the bank, the money that we borrow here, that's going to be called the principal. And then what we want to do here is we're going to use an equation here, and it's going to be the compound interest equation, okay, to figure out how much we're going to spend altogether when we pay back the loan, when we pay back what we borrowed from the bank plus the interest that they're going to charge. Now remember, what compound interest is when you pay interest on the interest. So when you earn money, earn money can go both ways. Okay, if you're making an investment and you earn interest, they will add the interest to your account so that the next time interest is calculated, it's calculated on that slightly larger amount. So then your interest grows and grows. Well, the same thing happens with a debt. Okay, they are going to calculate the interest that you owe, but then they're going to add it to the amount of money that you owe. So what you borrow gets bigger and bigger. And we're going to use this equation right here to help us determine how much it is that you're going to owe. Now, I just want you to know before we get into this, that the way we're going to use this particular equation in this course is we're going to assume that you're going to borrow the money right up front and that you're not going to pay anything back until the very end of the loan. Okay? And then what you do is you're going to pay everything back all at once. At least that's how we're going to use this formula here. So this is going to determine how much money we would owe at the end of the time that the bank is allowing us to have that money. Okay? So that's not the way most banks work. The way most of the time you get a loan is what you're going to do is you're going to have an agreement with the bank and you're going to pay it back in these regular amounts, like every month, every week, or whatever. And so you're going to make the amount that you owe smaller. And so every time they calculate the interest, there's a slightly smaller amount in there. The interest tries to make it larger, but you keep paying it back on a regular basis and knocking that down. So when we use this in this course, we're going to assume that you're not going to be making any of those extra little payments in there. And so this is going to be like the maximum amount that you would pay back to the bank. So here's what the pieces are. A is going to be the accumulated amount of the loan. So that's how much it's going to cost us altogether. P is the principal. So this is the amount that we're borrowing. And then we've got this 1. Now what the 1 represents here is 100% of the loan, the amount of money that you owe them, you're going to have to pay back, plus, and the rest of that is going to be the interest. Okay, so plus the interest that we're calculating. And this is how the interest is going to be calculated. We're going to take the annual interest rate, okay, so that's per year, so that's percent per year. But the thing is, the bank is going to do some compounding. And what we mean by compounding is that's when they calculate the amount of interest that you owe and add it to the amount. Okay, that's compounding. So the bank is going to do that over a certain number of times a year, and it could be once a year, twice a year, 4 times a year, it could be monthly, it could be weekly, whatever. And what they do here is they're going to take the interest rate that you owe them, and they're going to divide it by the number of times they're going to compound it in a year, the number of times they're going to calculate it. So just to make the math easy here, let's say that you're paying 6% per year, and it's going to be compounded twice a year. So what that means is they're going to, you've borrowed the money, they're going to wait till June, okay, 6 months, they're going to calculate the interest, add it on. Then they're going to wait till the December, calculate the interest and add it on. Okay, so they're going to do it twice a year. So what they're going to do is instead of calculating 6% at both times here, they're going to take that interest rate and they're going to kindly cut it into half. Okay, then what they're going to do is they're going to increase. Okay, they're going to increase this to an exponent, okay, where the number of compounding periods, actually I'm going to have to zoom in on that, I think. Whoops, wrong way. Okay. The exponent here is going to be the number of compounding periods per year multiplied by the number of years. Okay, so we're going to divide the interest rate by the number of compounding periods per year, add that to 1, and then we're going to take that to the exponent, okay, to the n multiplied by t. Now, before we get into this totally, I want you to be aware that on your calculators, when you do that, you're probably going to enter it like this: p bracket 1 plus I divided by n, and then you're going to use this symbol right there, to the power of, and then people are going to put nt, and they're going to get mad at me because it's not working. Okay, and you're going to look at me and say, but it's exactly what you said, and I'll have to look at you and say, no, no, it's not, because you need to put parentheses around the exponent. Okay, and that will be the part that's missing, so you want to make sure that you do that. Okay, so now, wrong way. So now, before we move on and do a couple of the examples here, the compounding period is the number of is the period of time after which the interest is calculated and charged on the loan. So it's generally the number of times the interest gets calculated in a year. So semi-annually, we want to make sure you catch that. Semi-annually is twice a year, and then quarterly is going to be 4 times a year. And there are other ways that you can do that, but those are generally the more commonly referred to ones. Now, you have got in your lessons here a demonstration where you've got a few questions, and then I've worked through the examples. I've written those out for you. So what I want to do here is I'm going to let those kind of explain themselves. I'm going to jump ahead to the examples that we would normally do in class together. Okay, so our first example here says Roger needs a loan of $8,000 to start a small business. If he decides not to repay the loan until the end of the 5-year term, how much will he repay if it was borrowed at 4.5% per annum, compounded, and then this is what's going to change here. So let's set up the equation here. So we know that it's going to be, and actually I'll write the equation up here. We know it's going to be A is equal to the principal times 1 plus I over n raised to the power of nt. So that's what we're shooting for here. So this is the accumulated amount, don't know what that is. It's going to be 8,000, that's how much he's borrowed, times 1 plus, okay, 4.5%. So first of all, I'm going to convert that into a decimal. And notice it's not 0.45, it's 0.045. 0.45 would mean 45% interest compounded. That's crazy. Okay, 4.5%. Okay, we're going to compound it semi-annually, so n is going to be 2, so we're going to divide by 2. And then this is going to be to the power of 2 times 5 up in the exponent. Okay, so that's going to be 10 here. So now I'm going to pull up the calculator here, and let's enter that in. So 8,000 times 1 plus 0.045 divided by 2, close bracket, to the power of. Now, my calculator actually raises those up into the exponent. So when I go 2 times 5, my calculator recognizes that that's in the exponent. For some of you, you're going to have to, like I said before, use the little button right here on your calculator, to the power of. Or some of you might even have to use the x to the y button. Okay, you'll have to use x to the y. But if you do that, you're still going to have to put brackets around the 2 times 5 to make sure that the calculator knows that that's the exponent. Now I press enter, and it looks like all together here, okay, Roger would pay, if he didn't pay it back until the end here, $9,993.63. Okay, but what if he does it quarterly? So that means that interest is going to be compounded 4 times a year to the power of 4 times 5. Okay, so now it's the same thing. And in fact, what I'm going to do is I'm going to go up here, and I can do this on my calculator, and some of you can do this as well with yours. I'll just press enter to grab that again. And now I'm going to go back and just edit that 2 and make it a 4 in both cases, okay, because that shows up in that fraction and up in the exponent. And now when I press enter, oh, now look at that. That's $10,006, and that's it. So this is going to be $10,006 and no cents if I round that to the nearest cent. So notice that actually increased it by compounding it a little bit more frequently. It actually increased the amount that we're going to pay back. And then here, if we do it monthly, That will be the 8,000 times 1 plus 0.045 divided by 12 this time, because it's monthly. And then to the 12 times 5. Okay, let's do the same thing. So we're going to go up and grab that equation again here. Whoops. Now, I got to change that 4 to a 12. And I got to change this 4 also to a 12. Press enter. And now, look at that. It's $10,014.37. Okay, so $10,014.37. Now, to go from semi-annual to quarterly to monthly, what it's gone up by hasn't been huge. But now think about that though. That's just because the loan was only $8,000. Okay, I mean, if in a lot of cases here, the loans you need to start a business are substantially larger than that. So anyway here, take a look at this next one. What is the total cost of the loan if he makes monthly payments of $148.99 for the term of the loan? Okay, see, this is now how this would usually happen. So you've gone to the bank, you've negotiated with them, and they have given you this regular payment option here. And so now all you're going to do is worry about that. When you get a question like this, when they've given you the regular payment, you don't need to worry about the compound interest equation. You would only worry about this if you wanted to know, well, what would I owe if I didn't pay it back until the end? Like, that's how we're using that equation right now. So here, what we're going to do here is our total that we're going to pay is going to be that $148.99. Now, we're going to pay that monthly, which means 12 times a year. And if you go back to the original question here and just kind of scan through it, it was a 5-year term. So that means we're going to pay that amount of money 12 times a year for 5 years. So this is a much simpler calculation. Still going to pull out the calculator to do it here. 148.99 times 12 multiplied by 5. And that means I'm going to pay back $8,939.40. Okay? Now, notice that that is, substantially smaller than what it was when it was up here compounded semi-annually. But that's the whole point. I mean, if you pay it back regularly, you will pay less, because what you'll do is every time you make a payment, you're making the amount of money that they're calculating the interest on smaller. It's like you've got this thing that's trying to grow, but you keep chipping off a bit of it at a time. And in fact, you chip off more of it, or I should say it like this, you're chipping it away faster than it's growing. So eventually it's going to go down to nothing. So now how much interest will he pay in all of the above options? Okay, so here's our options here. It's semi-annually, quarterly, monthly, and then we're going to do the regular payments. Okay? Now, in every case here, the original amount of money that I borrowed was $8,000. So $8,000 of each of these scenarios is just dedicated to me giving the money back, or in this case, sorry, not me, Roger giving the money back to the bank. Okay, so that's not interest. That's just you giving back what they gave you. Anything that you spend beyond $8,000, that's interest. So if we take a look at the semi-annual one here, okay, we paid $9,993.63. We'll subtract $8,000 from that, and we paid $1,993.63. Oops, can't see that, sorry. Now let's go to the next one. Quarterly. Well, Roger paid $10,006, and that was it. But he only owed $8,000. So he paid back $2,006 in interest. When we went monthly, we paid $10,014.37, but we owed $8,000. So he spent $2,014.37 in interest. But for the regular payment one, and actually this one's a little bit easier to calculate because we spent $8,939.40. Well, that is $939.40 larger than $8,000. So by making those regular payments, we pay back less in interest. Okay, so let's take a look at this question here. Liz needs $9,500 for her business. One bank offers her a 2-year term with monthly payments of $437.19, and a different institution offers her a 3-year term with monthly payments of $306.31. So how much would Liz have to pay back in each loan? Well, let's call this one, the first one here, A. We'll call this other one here B. So in A, the total that she is going to pay back is going to be $437.19. We're paying that back monthly for 2 years. Okay, so 12 times a year for 2 years. So that's going to be $437.19 multiplied by 12 for each payment per year, multiplied by 2 for both years. So calculator says we're going to pay back $10,492.56. B, the total is going to look like this. It's going to be $306.31, 12 times a year, but this time for 3 years. Okay, so now it's going to be 306.31 multiplied by 12 multiplied by 3, and we get 11,000, why am I doing that? $11,027.16. How much will she pay back in interest in both scenarios? Let's take a look at A. The interest is going to be what she paid minus what she owed, and what she owed was $9,500. Okay, so that's going to be, okay, we'll clear this up here. That's going to be $10,492.56 minus $9,500. Whoops. I'm going to try that again because I missed a zero there. $9,500. So it's going to be $992.56. How much is she going to pay in interest? At institution B, she paid back $11,027.16 minus $9,500. Well, let's take a look at that one. So 11,027.16 minus 9,500. And in that second institution, she's going to pay back $1,527.16. Now, give one reason why Liz might choose one option over the other. Okay, she might choose A over B, okay, because it will cost her less. Okay, it will cost her less in the long run. Okay, ultimately, like look at this with A, I'm spending significantly less money in interest. So that's one consideration. However, she might choose B, even though it's going to cost her more in the long run. She might choose B because it is cheaper in the short term. Okay, so let's say she's starting her business here, but money's just not coming in as fast as she would like. Well, maybe she needs to negotiate a loan with a smaller monthly loan payment, even though she's going to pay more in the long run. It helps her to survive in the short term, in the kind of the here and now. So there's two different things to consider there when you're looking for a loan.